CAPS is an Arduino-based printer that uses a pen. It has 3 servo motors, 2 of which are wheel motors that continuously rotate. The other is a 180-degree motor that is used for the dropping of the pen. The versatility behind CAPS is that it can be programmed to write on a large poster such as a 10 by 30 panel, or on a small paper size such as A4 paper.
Printing has come a long way, from woodblock printing to Gutenberg's printing press, all the way to 3D printing. The printer has evolved, and I feel as though CAPS offers another innovative form of printing through its Arduino system.
It prints using a library of stored letters within the Arduino code. So you would think with this capability, CAPS could potentially print out drawings as well.
Because printer ink has become so expensive as of late, the intention of our innovation was to offer a more simple, more affordable form of printing through its use of pens and Sharpies.
CAPS was especially creative in the student market segment, as well as those looking to cut costs of their printing expenses. It's a functional product that is designed to not only fulfill the functional printing needs, but also expand the horizon of modern-day printing. If you think about it, CAPS opens the doors to future printing technology that involves more portable devices and cheaper alternatives to present-day systems.
The simple-to-use replacement pen system allows for easier replacement of ink and offers a portable and potentially cheaper option, especially for college students who frequently find the need to print out paper, study guides, worksheets, exams, etc.
CAPS uses an accelerometer to turn on. When you shake the robot up and down in the z-axis direction, according to the accelerometer will detect movement and begin writing. Once it's done writing, it will reset and wait for movement again. We use the imposition of the 180-degree motor to implement a novel way of writing. The pen has 3 positions that strike the paper: left, middle, and right. By controlling the continuous servos that control the movement of the robot, we're able to digitize words using these simple 3 states of left, middle, and right.
The design of CAPS is quite simple. Using a standard Bobot with a breadboard on top, we managed to create the basic frame of our project. Then we put a Sharpie on a 180-degree servo motor, which fits between the glass and the body of our Bobot. After everything was set up, we connected all the motors to the Arduino using regular wires.
Basically, we hard-coded all the letters into CAPS, and you can see that in the stroke movements here. We technically use the forward and backward functions of the Bobot as well as the 3 positions of middle, left, and right to continually move the pen and the Bobot to write out all the letters. At first we had many options in how to control the movement of the pen, all of which were very demanding in terms of mechanics and code. From using magnets all the way to using the mechanism inside a floppy disk drive, we searched for many different options. In the end, we chose the simplest method of dropping the pen, the 180-degree motor. The 100-degree 80 motor can be coded to be very precise and can turn very specific angles, unlike the continuous rotation motor.
The accelerometer is connected on the side through pins A0 to A5.
There were many difficulties in including the accelerometer. We decided to only measure the acceleration in the z-axis to avoid any noise in the x and y-axis, and yet still the Arduino picked up noise from writing and would restart itself mid-process. Thus, we had to continuously raise the threshold of movement and find the correct balance for the acceleration such that the noise would not be a factor.
At first, when we were simply drawing lines, we noticed how every time the pen lifted, it would continue to strike the paper, causing it to look slightly messy on turns. Our original plan was to program functions so the Bobot could do right angle and left angle turns. However, the imprecision of the Bobot, as well as the mechanical difficulties involved in lifting the pen, caused us to scrap the idea entirely and look for a better one. It was then that we decided to use the pen mechanism imprecision to our advantage and use it as a base of our printing model.
I truly feel that CAPS can pave the way for a different and more portable type of printing.
We would like to thank Professor Lee, Sid, Parth, Sid2, and all the ESC 111 TAs for giving us the opportunity and resources to create CAPS.